Hello friends, in today's question, an alpha particle of mass m suffers one-dimensional elastic collision with a nucleus at rest of unknown mass. It is scattered directly backwards, losing 64% of its kinetic energy. The mass of nucleus is. So we have an alpha particle. So let us suppose this is the alpha particle and it is having a mass m, and it is moving with the velocity v, and this is the nucleus, and let us suppose its mass is given as capital M, which is at rest. Now after collision, this alpha particle moves with the velocity in the backward direction. So under this condition we say if this is alpha particle having mass m and after collision it is moving backward with the velocity of v1, and nucleus of mass m, let us suppose it is moving with the velocity of v2 now. And here its velocity is 0. So this is before collision, and this is after collision. And it is also given that the alpha particle loses 64% of its initial kinetic energy. So we said that mass of alpha particle is small m, mass of nucleus is capital M, mass of nucleus is capital M, and we see that initial velocity of alpha particle is v, and after collision its alpha particle is v1. After collision velocity of alpha particle is v1. Now it is given that it loses its 64% of energy. Therefore we can say the amount of energy that is left with the alpha particle will be equal to 36%. Therefore from here we can say alpha particle loses 64% of its kinetic energy, which is initial kinetic energy. Therefore we can say that final energy of alpha particle will be equal to 34% of initial kinetic energy. And the final energy of alpha particle, final velocity is v1. This comes half m v1 square, 0.34 multiplied by the initial kinetic energy. Initial velocity is v, so this becomes half m v square. Sorry, it is 36. Half m and half m cancels out, so we can write the equation as v1 is equal to 0.6 times v. Let's suppose this is equation number 1. So energy gained by the nucleus will be equal to 64%. So you can see energy gained by nucleus will be equal to 64% of energy of alpha particle. And after collision, let us suppose v2 is the velocity of the nucleus. We can say half capital M v2 square is equal to 0.64 into energy of the alpha particle, which is half m v square. So energy here is initial, and we say that v2 is the velocity of the alpha nucleus after collision. Velocity of nucleus after collision is equal to v2. So here this half and half cancels out. So we get the relationship v2 is equal to square root of small m divided by capital M multiplied by 0.6 times v. Let us suppose this is equation number 2, and the collision is elastic, so we are going to use conservation of momentum. You can say according to conservation of momentum, before collision momentum was mv plus capital M0, because nucleus was at rest and the alpha particle was moving with the velocity of v, and the final velocity is our m2 minus mv1, because the alpha particle is moving in the opposite direction after collision. Therefore, we can say that mv is equal to mv2 minus mv1. Let us call this equation number 3. So we already know the relationship v1 and v and v2 and v from equation 1 and 2. So using equation 1 and 2 in equation 3, we get, you can say mv is equal to capital M. V2 is our square root of small m divided by capital M multiplied by 0.6v minus small m, and our V1 is 0.6 times V. So we can combine it, and we get this as let me solve it first. We get mv is equal to multiplying m inside, we get square root of m times m 0.6v minus m times 0.6v. So we can cancel out initial velocity, and now we can make some adjustment. We take m as common, so we get 1 plus 0.6 is equal to 0.6 times square root of m times capital M. We can say this will be 1.6 divided by 0.6 is equal to square root of m times capital M. Square root of 64 is 8. My mistake. This will be 8. Here also 8. And here also 8. And this is also 8. My apologies. So we get this as 2 times m is equal to square root of m multiplied by capital M. Now we are going to square both sides. This is squaring. Both sides. We get 4m square is equal to m multiplied by capital M. Here m and square cancels out. We get mass capital M is equal to 4 times small m. This is the mass of the nucleus. This is mass of the nucleus. So from the answer, you can say it is option number B is the correct option. You can say that option B is correct. This completes the question. Thank you.